So my name is Sundaresan. I am the Senior Vice President for Silicon Carbide Technology and Operations at Navitas. I came to Navitas in 2022 through the GaNSafe acquisition, where I spent 15 years working on silicon carbide power devices. Now, as Gene said, yes, to the outside world, GaNSafe was like probably the best kept secret. To people inside the silicon carbide world, GaNSafe is no secret. I've been personally working in silicon carbide for the last 20 years. When I started in silicon carbide, we were working on less than 2-inch wafers, right? Even pieces of wafers. And it's been really gratifying for people such as myself to see silicon carbide finally going mainstream and into all these applications, right? So we've kind of watched, we've had front row seats, right, to the journey of silicon carbide, and it's an extremely gratifying kind of thing for people such as me who have been in this for a long time. All that being said, I also want to really thank the Navitas team for really accepting us, the GaNSafe team, right, as part of the Navitas family. So myself and almost all of our 20 key people have made not only the transition to Navitas as a company, but also have moved themselves and their families all the way from East Coast in Virginia. Most of us now call Torrance and surrounding areas home. Okay, with that, let's get started. As Dan said, GaNSafe has the widest MOSFET portfolio in the world, silicon carbide MOSFET, that is. We have parts ranging from 650 volts all the way to 6,500 volts. Total of 60+ MOSFET products, ranging from discrete parts, bare dies, and power modules. So what makes the Navitas or GaNSafe MOSFET special? There are MOSFETs, of course, as you know, offered by a bunch of different companies. So what's so special about the GaNSafe MOSFET? Well, it's our unique and patented device architecture that makes all the difference, and I will explain briefly what that is. The first silicon carbide MOSFETs that were introduced in the year 2011 were planar MOSFETs, similar to what was done in silicon. You see, the silicon carbide MOSFETs have more or less evolved along the same lines as silicon power MOSFETs, but there are a few key differences that I will point out. The planar MOSFETs introduced in 2011 by Wolfspeed, easier to manufacture. They can be, as a result, manufactured with high yield and low cost. Performance-wise, they are not so great. They have a higher on resistance per unit area. They have slow switching speeds, and they also have a high on resistance increase with temperature. Planar MOSFETs can be designed and fabricated to be reliable. They are mainly rugged due to the use of their planar gate architecture. In silicon, as you may know, the limitations of planar MOSFETs were overcome by moving to trench gate architectures. So unsurprisingly, the same has been attempted in silicon carbide as well. Now, there are many vendors, as we all know, who have already offered silicon carbide trench MOSFETs into the marketplace. And some of those vendors are listed here, and you can also see some of the cross-sections of those devices that have been commercialized already. What is common to all of these silicon carbide trench MOSFETs is that they need extremely complex manufacturing lines, often requiring very exotic process steps. Typically, a trench MOSFET has 30 to 50% more process steps than does a planar MOSFET. Consequently, they suffer from lower yields, or I should say they are prone to suffering from lower yields. They also have a very high cost to manufacture as compared to planar MOSFETs. Performance-wise, yes, you can make trench MOSFETs with lower on resistance per unit area as compared to a planar MOSFET. That's true. They can be designed with faster switching speeds. But the big problem with trench MOSFETs, which have been commercialized so far, is that they have a very high on resistance increase with temperature. So they may be designed to have a low on resistance at room temperature, but as the temperature increases close to the use case operating temperatures, the on resistance really increases a lot for trench MOSFETs. So what we have done at GeneSiC is really bring the best of both worlds. We've taken the best features of the planar MOSFETs, the best features of the trench MOSFETs, and combined into what we call a trench-assisted planar gate MOSFET. This MOSFET is easier to manufacture, similar to a planar MOSFET. Consequently, it can be manufactured with high yields and with low manufacturing costs. The performance is where the trench-assisted planar really comes to its own, because it has the lowest on resistance per unit area, fastest switching, and the lowest on resistance increase with temperature. So you see, the trench-assisted planar gate MOSFET is manufacturability-wise similar to a planar MOSFET, but performance-wise, it can rival or even exceed a trench MOSFET. I know this sounds very surprising, but it's actually true, as I will show in the next slide. Reliability is also somewhere a place where the trench-assisted planar MOSFET shines. Since it's mainly a planar MOSFET, the MOSFET channel is planar. The gate is pretty rugged. However, we also offer the highest 100% tested avalanche ratings on our data sheets. So how does the performance of the trench-assisted planar MOSFET compare with the competition, planar and trench included? So the graph on the left shows you the static performance comparison. The graph on the right shows you how the switching performance compares with competition. So the Gen 3 fast version of the trench-assisted planar technology offers up to an 18% reduction in on resistance at 175C. It offers up to a 50% better switching figure of merit as compared to competition. If you combine the 2 points, what you get is lower losses and cooler operation. You can see the picture at the bottom right part of the screen. This is an in-circuit test conducted under identical load conditions on a GeneSiC MOSFET and a competitor MOSFET. You can clearly see that the GeneSiC MOSFET runs about 25 to 30 degrees cooler than competition. This leads to better system efficiency and a longer lifetime. Super important. OK, so here is our product roadmap for the next 2 years, 2024 and 2025. So in the early part of 2024, we plan to introduce our Gen 3 fast silicon carbide MOSFETs, Gen 5 MPS diodes, followed by Gen 4 silicon carbide MOSFET chips, which are specifically designed and targeted for EV traction applications. We follow that with top-side cooled silicon carbide MOSFETs. Our very first silicon carbide module offering will be the so-called SiC pack. It will be offered in multiple topologies up to 150 kilowatts. Later on in 2025, we plan to unveil and release our proprietary SDC power modules. This is specifically targeted for EV traction applications. Top cool power modules will follow for OBC applications. And finally, last but not the least, we plan to also release ultra-high voltage silicon carbide MOSFET modules at 3.3 and 6.5 kV voltage ratings. Here is how we expect our technology roadmap to evolve. There are really 3 guiding principles that we use to evolve this technology, the trench-assisted planar technology. Point number 1, continuously reduce the on resistance times chip area, because by doing this, we can increase the amount of current that you can conduct with a given real estate of silicon carbide. Mind you, very expensive silicon carbide real estate, as we all know. It also reduces the cost per ampere. Point number 2 is improve the performance over the entire operating temperature range. Don't just focus on room temperature or just at high temperatures. Improve the performance throughout the temperature range. This is a very key point and will distinguish our technology specifically over trench MOSFETs, which are primarily optimized for room temperature operation. Point number 3 is to continuously optimize the design as well as process to meet the ever-increasing demands from customers for increased reliability, increased quality, and increased robustness. So we started in 2018, where we released our baseline version of the trench-assisted planar technology. We called this the Gen 2. In 2021, we launched Gen 3 with a greater than 17% reduction in on-resistance. In 2023, we are about to unveil our Gen 3 fast silicon carbide MOSFETs, which in addition to achieving greater than a 12% on-resistance reduction, optimized driving, has better dynamic performance. That's what gives it its fast switching, and also will be fully automotive qualified. Beyond Gen 3 fast, will follow Gen 4, which has a further shrink to the unit cell. So again, it's the same unit cell that we're using throughout these generations, right? So it's by shrinking the unit, the unit cell shrink is achieved by layout and process innovations. And this will result in greater than a 10% reduction of the on-resistance. Finally, we are already doing extensive R&D on what we call our Gen 5 MOSFET. This is a radical, or this will be a radical, high power density technology. And this will have the capability to dramatically lower the conduction losses, especially at elevated temperatures at 150 to 200 degrees Celsius. And in fact, we are targeting greater than a 25% reduction on resistance at high temperatures with Gen 5.